Hi everyone, welcome to this MongoDB session. We're going to talk today about a story, about a company that wants to build something nice, something fancy we're going to use a healthcare solution with a subject that really matters to everyone, I think, about how to prevent cancers. So my name is Fred Favelin, and I'm here with my two great friends, Rick and Shane.
Excellent. I'm Shane McAllister. I'm on the MongoDB developer relations team. I'm one of the leads there. And I look after our partners, so it's great to be at AWS. It's great to see the crowds here, and I'm looking forward to our session today. Rick?
Rick Houlihan, I'm Field CTO for Enterprise here at MongoDB. Many of you might know me from my days at AWS. I was the first Enterprise SA for DynamoDB and left AWS about 3 years ago as a worldwide technical leader for NoSQL. And again, here to talk to you guys a little bit today about open source blueprints and building AI apps. So today we're going to talk a little bit again why. The first thing we'll talk to is why blueprints, right? Why do these things make sense for developers? And then a little bit about why MongoDB. And that's why I'm going to talk to you a little bit about is, what is MongoDB doing that's so unique in the AI space that's something that makes it important for you to be aware of us. And then we'll get into, Fred will break down a little bit on choosing the right open source blueprint. Shane and Fred will get into this content, and we'll talk a little bit about an interesting program that we run, the MongoDB AI Application Partners program. And then we're going to get into an example architecture of actually building the system that Fred was just talking about. So the first thing we're going to talk to is why blueprints, right? Why are blueprints important for you as a developer, as a business owner? And what's interesting to look back a little bit in time here, in 2019, right, MIT Sloan School of Business did a survey of organizations and felt that, and got a response back saying 97% of those organizations felt that AI was going to give them a competitive advantage. Right, this was in 2019. Okay, fast forward 5 years, and if you aren't using AI today, then you pretty much are lost, right? So, I mean, the future is here, and it's here today. And the reality is that it's not easy to use these tools, right? And there's a lot of things that we can do to make things better for us, right? We can improve the employee experience, right? We can reinvent customer engagement, right? As we kind of use AI tooling to process social media events, we have customers who are doing this to kind of measure customer sentiment in real time and take action. We can reshape business processes, right? I have other customers that have reduced business processes that takes months, and we'll talk a little bit about this, to 10 minutes, literally, with AI tooling. And we can essentially bend the curve or reshape the curve on innovation, right, with AI. So obviously, there's a lot we can do with AI that will drive that competitive advantage, but getting this done, right, making it happen is not easy. Right? When we look at what's happening with Gen AI adoption, it's happening in fits and starts across industries, and the reason why is because there's a continuous evolution of this tooling that's going on. Right? Every day there's more features, more functions, more tooling, evolution of the technology, and we lack the expertise, right, internally to be able to do this, to be able to build these pipelines and essentially connect all of these technologies to create these ML pipelines. So integrating these disparate systems, right, this is really the reason why blueprints really make the most sense. Because we can take tools that are connected, create pre-built ML pipelines for meaningful purposes, and use those and redeploy those for our own use, right? So, getting through that's great. So why MongoDB? Right? Why do we really care about MongoDB, and what does MongoDB bring to the table here? And what it comes down to, it's the core to our mission. We've always been about simplicity, right? Everything about our product has been about making things easier for developers. And as Albert Einstein once said, right, everything should be as simple as possible, but not simpler, right? And it's an easy thing to say, not necessarily an easy thing to do. And as we all know, our organizations have lots of legacy applications and data locked up in those applications. As we moved all of this stuff into the cloud, right, we were going to gain some great evolution and great efficiencies, and we did, right? We got some evolution, there's some efficiencies from this, as we're no longer in the business of building data centers and running data centers. But really, that lift and shift of all of that technology has only created a situation that the modern applications are not necessarily going to benefit from, right? Those modern applications have requirements that go beyond what those legacy technologies were built for. When we get into the realm of AI, right, we need to support vectors, right? We need full text search, we need time series, right? We need lots of different functionality from our database, and legacy databases weren't built for this. So in the cloud now, we have all these options. We have this sprawl of purpose-built services that are up there for us to bolt on to our legacy operational data stores, but this is not doing us any favors, right? It's actually just increasing the complexity as developers developers now are forced to build systems over and over again, essentially bespoke architectures, over and over again, what I call wobbly towers of technology, as you're now forced to essentially connect these silos of functionality on top of your operational data store, maintain those ETL pipelines, and all of that plumbing and all of that overhead becomes your responsibility. And again, this is something that MongoDB has always pushed back against, right? We have been about simplicity, and one of the things that we've always seen in our customers is when we see them doing the same things over and over again, we take a look at it and say, is this something that we can actually bring in to do for our customers and integrate this functionality into our platform? And this is really how Atlas was born, right? But Atlas wasn't the beginning of MongoDB. MongoDB actually started with the core database, and the founders really realized that working with the relational database was unnecessarily complex. Essentially, it's an abstraction of the data. You don't store the data in the relational database the same way you use it at the application layer. As a matter of fact, if I need to retrieve a complex object from the database, I need to write a complex query in a totally different language to be able to get that data. Right? This is essentially an impedance mismatch for developers as they fight through this, and a lot of developers essentially punt. And the models that they build in the relational database are not as efficient as they could be. Developers are essentially being forced to translate how you code into how the data is stored, and it slows you down. Okay, and we've demonstrated this over and over again. The other problem with the relational database is operationalizing and scaling the relational database. Again, it was never built for this. It was built in the 70s when replication across regions and geographical consistency was not an issue. Okay, so this is something that we actually built right into the replication protocol of the database itself. When you make a write into MongoDB, you can choose what kind of consistency you want across all regions that you have your data deployed. Right? It says unique experience for developers in working with their data. You store the data the way you use it. We can operationalize the data in ways that you cannot do in the relational database, and we scale gracefully. And as application requirements have expanded, what we've seen is that the complexity of building applications grew, okay? When you add on time series, full text search, real-time analytics, stream processing, right? Vector search now with AI, there's just more and more capabilities that modern applications require that developers were having to bolt on to their database over and over again. And this is why we built these needed capabilities into the platform, right? Requirements like time series, full text search, vector search, online archive, these types of things that are built right into the platform so developers don't have to implement that functionality themselves. And it extends right into the AI, right? So this is really what we've delivered when we look at this platform. It's all wrapped up into a unified API, right? So one place the developers need to go to. You don't need to query multiple systems to get access to your data, right? With a lot of databases today, if I need full text search, I put Elasticsearch. I need to ETL my data into the Elasticsearch instance. I can query my Elasticsearch database, and what does it do? It gives me pointers to the data in my operational data store. I have to go back and get that. Right? So if you're using Elasticsearch for your vector index, you're not necessarily going to be able to get your data right out of Elasticsearch. You got to go somewhere else for it. That's latency, that's added overhead, and that's complexity. MongoDB's developer data platform essentially wraps all of this up for you in a single API. Right? You make a vector query in MongoDB, the data comes right back with the results. You don't have to make a secondary query, you don't have to project data into a secondary data store, and you don't have to maintain the data consistency and the ETL pipelines that are required to push that data across multiple data stores. Right? It's one place that you go, one API that you use, and this is why developers have flocked to MongoDB over the years. Over 50,000 paying customers use MongoDB. This doesn't include our open source product. We have hundreds of thousands of deployments on our open source platform, and 175,000 developers a month are looking at MongoDB for the first time. One of the most popular, if not the most popular database today is our platform, is MongoDB. And we continue to grow. AI is now reigniting all of this sprawl that we just talked about, right? I mentioned vector indexing. Vector indexing is a real small part of the AI workload. And what we're seeing is that the risk of this added complexity creeping right back into the operational data store again. Right? With the need to support AI workloads. Now I have Pinecone, I have PG Vector, I have so many different options out there to do my vector index, but the operational data is still needs to be retrieved, right? Needs to be stored, it needs to be accessed, right? So if I query Pinecone, I get pointers to the data, and I have to go query the operational data store to go get the data. We've got a system here that is introducing a lot of complexity and latency. We want to get rid of that. Now, to understand why vectors are important, right, in AI, and I'm sure a lot of people in the room here do already know this, but vectors are really a crucial feature in AI. They allow us to essentially store multi-dimensional representations of the data and collate data or correlate data together that would not normally be relatable, right? Things like images and audio files and rich document structures, right? And what's interesting here is that modern applications that are being built on, that are using AI functions, they're not using data the same way that the relational database was built for, right? In legacy applications, we use data in rows on tables, little bits and pieces, right? OLTP workloads, oftentimes when they execute, they're just working with individual rows. 70% of the access patterns when I was at Amazon were a single row of data on a single table across 10,000 services, right? 20% more for a range of rows on a single table. So 90% of the access patterns in those legacy OLTP applications, they're just working with rows on tables, right? Half the infrastructure was deployed to support the last 10%, right? So it was a major amount of investment to do the joins, really, is what it comes down to. But the reality is, with AI workloads, everything is a join because we need complex data, right? We're using with rich document structures, not rows on tables anymore, not little 2 kilobyte things or 100 bytes or a couple hundred bytes. We're talking about 4 kilobytes minimum. We're talking about megabytes of data, right? Things that are not, the relational database was never built for this stuff, and it doesn't perform well. As a matter of fact, feel free to check my LinkedIn out. I've got a nice benchmark there that we published on JSON-B performance in Postgres versus document performance in a tool like MongoDB, and it becomes immediately apparent that it's a problem, right? So one of the things we do with vectors, again, we correlate data together for workloads that require things like semantic search, right? One of the things that is popular these days we call retrieval augmented generation, right? The ability to go get the relevant data and feed it back into the model to get an updated response. Okay, we use this for diagnostics, we use this for predictive AI workloads, whatnot. But the reality is that we're leveraging vectors to get the data that we're feeding back into the workloads that we're generating these AI responses. And there's multiple ways that we can build, that graph or that label got a little tweaked there, but there's multiple ways to be able to implement vector indexing over your operational data, right? The first way is to use a standalone vector store. Okay, standalone vector database is a decent option, but the problem here is that it's the vectors that you're storing in the database, right? We mentioned this already. When I query the vector index, now I get pointers. The pointers have to go be retrieved. I got to go get the data that those pointers point to. So it's essentially 2 steps. Query the vector index, now go get the data. That's latency, that's complexity. The next choice is to use something like maybe a PG vector, right? Integrated vector solution where, and this could be an option if but when this falls apart because of a simple issue is that the vector workload will be competing with your operational data, right? One of the things we learned with Atlas a long time ago when we introduced full text search and analytics nodes was that users need to scale that functionality independently of each other, right? So our first implementation, we actually sent out there and users immediately came back and said, hey, I'm upsizing all the nodes in my cluster because I need full text search, but most of my data I'm hitting off of the secondaries. I don't need to have those upsized hardware resources for my operational data. So now, every time we release a feature, we actually release that feature as an independently scalable function inside the platform. So we can actually independently scale our vector workloads on the side from our operational data. Essentially, you can have different nodes with different configurations, different indexes, right, to support different workloads and different read patterns, different write patterns, right, and drive efficiency in the system and scalability. Right, one of the things you hear about these days a lot is, and I don't know if you guys are hearing it, but I'm hearing it in research circles, is this idea of a translytical database, right? The thing that one database, 0 ETL, all workloads, right? Transactional, analytical, all in one place. And it's a great idea. It's a great idea. We had that idea 10 years ago. It was Atlas, right? And what's very important when you start talking about things like translytical databases is being able to independently scale the silos of functionality that you need to support your workload. Because if I have to scale the node the same way for every piece of that workload, then I'm going to have to essentially oversize the entire cluster for every single access pattern, right? So we don't want to do that. So with independent scaling capability for vector, for full text, for time series, for anything you need, we give you the ability to support those workloads gracefully. And this is one of the reasons we announced vector search in 2023. It was actually one of the fastest adopted new services we've ever launched. Primarily for this reason, right? It's graceful integration of the vector index on top of the operational data with independent scaling of that functionality. And we're not the only ones, right? We were named the most loved vector database for the second year in a row in Retool's 2024 State of the AI report. Thousands of professionals, AI professionals, developers, project managers, business owners have weighed in and said that this tool is the most effective tool for them to build their workloads, their AI workloads. And honestly, this recognition validates our commitment to our customers and supporting the needs of our customers in this rapidly evolving market, right? And that's what we are about. We're always about enabling developers to do the things they need to do without having to focus on the plumbing. Right? The plumbing has no value for your business. Right? Maintaining ETLs, understanding cache coherency, data consistency across silos, interesting problems for computer scientists, right? Not necessarily interesting problems for your business, right? Let's focus on what matters, for your business. And there's a sampling of customers that have used, MongoDB tools to build, or as a tool to build AI-powered solutions. And all of these companies chose MongoDB not just because of the ability to bring together the operational data with vectors, but because it works for all of their modern application needs, right? We don't just focus on vectors. We actually power the operational data. We power the specialty workloads, time series, vector search, full text search, whatnot, and with many other capabilities together. And your applications require these capabilities, right? This is what we've seen from our customers over and over again. The reason that we put these capabilities into the platform is because our customers were doing it over and over again. And we felt that we could make it easier for them, and we have. And only MongoDB's unified developer data platform gives you that single API, right? As a developer, you don't need to understand multiple silos of technology, how to talk to multiple different systems, and understand disparate APIs. You only need to understand one. And we're seeing a huge demand for Atlas Vector Search since its launch as a result, from startups to enterprises. And one of the best examples I can bring to the table here when we talk about AI workloads, Novo Nordisk. 100-year-old pharmaceutical company. These guys, highly regulated industry. Every time they run a clinical studies report on a new pharmaceutical, they go through about a 6-month process that they go through to submit the clinical studies results across 100, 110 agencies around the world to get approvals. And when we partnered with AWS and LangChain to produce a solution for their problem, what we came up with was that they have essentially reduced that 6-month window to 10 minutes. 10 minutes. It's ridiculous, right? It sounds ridiculous. I wouldn't believe it if I didn't know that that's what the result was. But the impact was the reduction in the back and forth, right? Where every agency had their own little edits and their own little requirements, and I need to compile the data in certain ways. The AI tool was be able to essentially foresee those requirements and provide that data up front. So it lowered the overhead not only on Novo Nordisk, but all those regulatory agencies that needed to actually approve these as well. So huge impact that we're seeing from AI, and I love those types of workloads, right? Chatbots are great, and that's fine, but what's best is when things are actually really meaningful, right? We had great chatbots 10 years ago. I don't know if I need AI for that. That's pretty expensive technology for that. Anyways, this is the platform. This is what's available for you to use at your disposal, and we're going to let Fred and Shane talk to you a little bit about how do you get started, right? That is the biggest question I hear from our customers these days, so thank you, Fred, so much.
Thanks very much, Rick. So now, where do we start? And that's a great question. And we will start by trying to choose the right open source blueprint. So in order to do it, in fact, we have really to get our different capabilities in order to ensure that I'm going to write and use what will be really useful in order to build my applications or my different workloads or enhance my different applications to generative AIs and to go to the next stage. So the first thing that I need to do is really defining my use case. That starts with understanding my goals. What do I want really to achieve with Gen AI? Are we focusing on text generation, image generation, sound detecting, or building something else? Or maybe a combination of all of this. Then after, that's good, but generative AI is starting to generate data with existing data. So I need to identify also what is my data needs. I need to consider different type of data. Where I need to store them, what I need to do to process them. And really, this is where MongoDB Atlas came into practice. Because as Rick said, there is something that is great with MongoDB, that we are really well working with unstructured and semi-structured data. The next thing also is we have seen that we have lots of existing blueprints. You can find them over GitHub repositories, but also other platforms. And just doing some Google search with generative AI with MongoDB, you can find really lots of relevant repositories. However, are those repositories very well documented? Do you have any examples where we can have startup kits in order to really have something that will be really well documented? Do we have any learning resources also around it? But what is the quality of the documentation that has been provided? This is where we have also lots of things that have been released and that has been pushed, maybe once, twice, and at the end, not really that useful because of the quality of the documentation. Maybe the code is here, but not documented, and I will not be able to do anything without it. So there is something where I need to get tutorials, example, comprehensive guides. But I need also to learn. I need to check also about the tutorials and the quality of my tutorials in order to help me really to use it, how to build something out of it. And then what will be also, how is it going to be licensed, this tutorial? Is it an open source one? Can I do something out of it? Or is it something where I will not be able to use it, or just try? But when I will go into production, then here starts the nightmare. So that I may have lost a little bit of time because I need to go back to all the process, looking back to GitHub, repository, documentation, and all these things. But after, that's good. I find some blueprints that are good. However, I need to do a little bit of proofing out of it and see how it's going to work. So I need also, once I'm going to build something, need to check also about the community support. Do I have support when I'm going to build something out of it? So I need to check also the activity level around it. Need to find also within the different channels if you have got also issues, discussions around the community. And the stronger the community is, the better it is. But the reviews are also very important in order to select the right one. Because I need to get feedbacks about it, and maybe I've got bad feedback, so that is, I'm going to deprecate it. So I need to find something that where I will have a good support with great of activity, so that should, when I'm going to make my proof point out of it, I will get some support should I have any issues, so that maybe a bug will be fixed, and then I will be able to get something. But that's not only. I need also to integrate this blueprint within a full ecosystem that I have. Is it going to be well integrated with MongoDB, with AWS? Do I have the generative model that I have? And how am I going to scale? Because my application on day one will be maybe small. But how is it going to be within 1 month, 2 months, 6 months, 1 year? So I need to get something that is going to be able to evolve. And for sure, something that is way important is the security. My data need to be really fully well secured. And this is something where I need to adhere also with all the best practices for securing sensible data. And this is something that we will show a little bit afterwards within the demo, because data security is really key and crucial. But we need also, depending on the industry where you're working on, to be ensured that you've got all the compliancy. And this is where it's something that should be quite important also for you to ensure that when you're going to be able to deploy everything, you will get also all the compliancy for your data and your application, because it's something that is not only about the database, it's also about the application. So I've done it, I've selected it, I know that I'm going to be able to do something with it, selected the right blueprint, but now how can I do and work with it? And this is where I'm going to start my prototype. I need to create a prototype, and don't hesitate also to fork a couple of promising blueprints in order to see what is going to be the flavor around it. And for sure, test also the performance. The performance will be crucial for your application because this is going to lead also with the end user experience that you're going to get. And most of them may come also with sample of datasets, really to ensure that it will come also with your expectation, but use also your own datasets in order to validate within your use case and your environment that everything will be great. Now that's great, I've done my prototype, but how can MongoDB help in this sense?
Thank you, Fred. So, thank you. Given the success that we had with vector search and what Rick went through at the beginning since 2023, we got the questions from all of our customers and clients about looking for help to build their Gen AI applications. So this June at MongoDB.local in New York, we announced and launched what we call the MongoDB AI Applications Program, or MAP as the suitably short acronym that we can use too. So what is this and what's this for? Well, in today's competitive landscape, it's increasingly hard to leverage innovative technologies, but everybody wants to do so with Gen AI in the potential that it has to transform their applications, to transform their business and what they need to do. So MAP is a comprehensive solution powered by MongoDB and a number of our partners that you'll see shortly to allow you to do this in an easy way, a scalable way, and a performant way with advanced AI capabilities. So MAP's success hinges on the strong partnerships that we've built with the leading AI partners in the space today as well too. And by collaborating with these, we ensure that you, through the MAP program, have access to the most advanced technologies that are available today. So also, MAP is essentially a service offering from us as well too. So again, in trying to help customers build things quicker and faster, we have professional services offering things like strategic advisory and comprehensive technology stack demos and integrations, et cetera, as well too. So we're going to show you some of this. But to delve into, again, what Rick touched on at the start, this sprawl of development. And the stats, 65% of organizations claiming regular use of AI. It's a great stat. AI and generative AI in our space has been, 2 years. It's been machine learning and AI around a lot longer, but the generative AI that we know today, 2 years, really in the public discourse. And we're trying to take advantage of this shift, and all companies are trying to take advantage of this shift. But despite their willingness to create AI applications, many of them are quickly experiencing challenges and struggles. And these are manifold, but particularly with integrating their data into their AI models. And we're going to show how we help in that space. So in other words, their applications are working well, but just not well enough. In addition to the evolving AI landscape that we have there in the middle, plus the complex integration problems that most of our customers are seeing, there's 2 other things as well too. Legacy technology. They feel stuck with legacy technologies, and that's holding them back from being able to build and generate the applications that they want. They're trying to adapt to the shifting market conditions, but they're working with legacy technologies. And, they cannot manage that in real time. The multimodal that Rick talked about doesn't work with the legacy technologies as well too. And it just doesn't live up to the expectations that today's intelligent applications require as well. Secondly, and this is prevalent throughout, is they suffer from lack of expertise. This is a new space for most developers. It's a new space for most companies as well too. So they lack the in-house AI development expertise, and then that lacking increases the perceived risk of taking on these type of projects as well too, without a unified support system behind them as well. And they're leaving them to seek a trusted advisor to help them solve this challenge and solve the complexities of Gen AI development today. So, in addition to MongoDB technology that we have, we've created MAP to combine both the tools and services to help this problem, to help progress AI application development at every stage. Furthermore, the program is molded to fit companies' particular technical needs, particular budgets, and particular developers' experience and timelines as well too. So our MAP ecosystem, we've carefully selected and organized the integrations and the partners that we've chosen. We have built the MAP ecosystem with composability at its heart, the ability to lift and shift out different partners, different technologies as well too. We have wrapped all of this in expert services and support, so we're able to give assistance to accelerate development and minimize those risks that are associated with building AI applications at any stage, be that the prototype, be that the technology integrations, or even the production deployment as well too. And finally, part of the MAP program as well too is around enablement. Resources, including access to integration and development best practices, to allow your own teams to become highly skilled in developing their own applications as well too. So MAP as a whole accelerates the time to market, it minimizes the risks, and maximizes the value for your AI investments. So I spoke about the ecosystem, and what does this look like? We have combined together with most of the leading players in the AI space. MongoDB and its open architecture allows us to work with anybody, essentially. But for our customers, we assembled a set of the world's leading AI and tech organizations to complete out our stack in MAP. And by choosing these, the leading organizations themselves with us have committed to creating for our customers to demonstrate flexibility and the ability to tap into the AI space as well too. It makes it super easy to get started, super comforting to know that these are the companies that we've partnered with as well too. And so in selecting these partners and the architectural design that we've done in MAP, we have essentially created this ecosystem. It's just getting started. We're adding new partners all of the time. We announced a few just even in the last week. I think it's on our LinkedIn as well too, Fred. But we're allowing developers to create differentiated, production-ready AI applications whilst aiming to deliver a substantial return on investment. So it's important to note that given the composable nature, some people might say, well, I can choose any vector store as well too. And that's fine, but we cannot lose sight, as what Rick went through at the beginning, of the key core values that MongoDB brings and provides, generally speaking, within these architectures. So these core values is it's a unique data store for your operational data and your vector data. As Rick pointed out, we're avoiding any ETL. We don't have to build it, we don't have to maintain it. We don't have to maintain the additional overhead either. And from that perspective, there's a better user experience all around. It's a unified developer experience, our developer data platform, all of that Rick went through to detail. MongoDB Query API can access all of that. We've also gone a little bit further to make sure that developers creating applications on MongoDB have the tools that they use basically informed by MongoDB best practices. All developers these days are using code assistants. There's a number of them out there. We've fine-tuned and trained, in particular, Amazon Q Developer. We were invited over a year ago to understand how Q and Code Whisper, as it was back then, works with developers, and to make sure that any developers using those, invoking any commands, any kind of connection back to MongoDB, were getting best practice code returned to them on the basis of their prompt as well too. So we're enhancing developer productivity in writing that code in the first place. Of course, MongoDB accommodates the exponential growth that a lot of these AI applications are going to bring to the companies. There's no hard stop, thanks to Atlas's autoscale. And as we discussed, we have native vector search capabilities and the ability to not get bottlenecks with vector optimized search nodes as well too. So from a developer data platform point of view, whilst composable in any of these architectures that we propose, MongoDB is still the best fit. So what we've done in the initial space is to look at one of the applications of Gen AI that's most frequently used by our customers and most companies, which is RAG, Retrieval Augmented Generation. And how do we help that? Complemented with the suite of all of the partners that we have, and also with vector search, Atlas search, stream processing, etc., to build your architecture and to provide something that can get you started really quickly and something that gets you started confidently, knowing that it'll work as well too. So the components of the AI stack brought together in Retrieval Augmented Generation are considerable in terms of what you might need to put together. And as we saw with the partners that we put up, we needed to have some specific knowledge. We needed some domain-specific expertise. It needed to be cost-effective in terms of its delivery, and it needed to be trustworthy as well too. You needed to know that this was scalable going forward into the future as well. So the structure, and we won't have a lot of time to go into this in detail, but I do touch on a couple of them in the next few slides. The structure of our architecture for RAG in MAP looks exactly like this. So over in the top left, we've got obviously just the user and the query, but what happens in that process? We have predefined all of this, pre-designed this architecture underpinned by Atlas and all of our partners so that it makes our developer data platform super easy to use. The pre-query retrieval, the post-retrieval, the integration with the LLMs, the data indexing, along to the embedded models, the prompting, etc., all leading back to Atlas as well too. So if we discuss a little bit about clearing the way for AI innovation in any company, the cornerstone of this is MongoDB's own technology. You know, AI innovation needs to be for any use case. It needs to work with any models that are out there as well too, any cloud and any data type. That sounds very similar to what we do here in MongoDB. We can work with any use case. We can work with any LLM provider in the MAP framework as well too. MongoDB is cloud independent. We are on the 3 main cloud providers, and we are the only database company that can do multi-cloud. So you can have your data across all of the clouds as well too. And that might be due to geographical regions, legal regions, et cetera as well too. So you can leverage any cloud provider, and the document model, as Rick described in the beginning, is the most suitable for what essentially Gen AI applications are, which are very modern data workloads. So we talked about looking at blueprints, we talked about data. There's a few things to be knowledgeable about your data in terms of getting your data into MongoDB as part of any generative AI application in the first place. We've got loaders for so many different file formats as well too. Confluence pages, Microsoft Word documents, PDFs, PowerPoint, website maps, static websites, YouTube channels, and even YouTube search as well too. So help you bring in all of your data regardless of its original format or location as well too. But there's a couple of things that you need to be wary of with regard to this data. So data indexing prepares raw data for efficient retrieval and search operations. Large language models often rely on extracting and formatting from databases and files like PDFs for them to understand and utilize the private knowledge within as well too. So that's really, really important. The next one is pre-query retrieval. So this step allows you to make sure that your query is optimized for retrieving the most relevant data from MongoDB. The response from an LLM is only as good as the prompt that you provided. So understanding that the user utterance and enriching the prompt with relevant contextual data becomes key to getting accurate responses back from that LLM. And also avoiding hallucinations, as we all know, is possible if we don't do that properly. So that's how that looks in reality. Query rewriting, query rerouting, and then expansion of that query once it has been returned. And post-retrieval processing is the third thing that ensures data is refined and presented in a useful format back to the end user. So generally, there's a context window size that LLMs operate within, and the contextual data is retrieved from multiple sources or retrieval techniques. So we need to combine these results in a coherent fashion before creating the prompt to the LLM, and that is a critical part about creating your generative AI applications. So we've discussed the theory, we've discussed the scale, we've discussed where MongoDB fits in as well too. We want to get to a concrete example, and as Rick said, chatbots, we don't want to do chatbots. So we want to do a really well-performant example. Last October was Breast Cancer Awareness Month, and this is something that affects people indirectly or directly throughout the world. At least 10% of women will encounter this at some stage. And it's really through the efforts of the screening and pre-screening and testing that all of this has been reduced to a minimum, saving hundreds of thousands of lives. And what we looked at is a larger case study, and we have a bigger example and demo of this. We don't have time to go through all of it today. But we thought, what would an application built on Gen AI look like that could give the most up-to-date information to doctors, clinical staff, and patients? So that's what we're going to try and show you today. So Fred, let's get started.
Thanks, Shane. So let's get started. And something that is really important, and with breast cancer, but any kind of cancer, is about the prevention. And the prevention for us is really how we are going to start. And we know that we had this Pink October, where everyone and every woman are really initiative in order to get the test. And this is all start with the mammography, and we've got some dedicated centers here within this company example, where women can really go and take a mammograph. And there is also some programs that are here in order to to streamline and process the mammograph, but also do the follow-up around it. Now, if we look at a little bit into practice, how it's working, and a little bit of the architecture on the different components that we will need in order to build it. And we will start with the document model one more time. And this is something that is way important, because you will see that with this health data, we need a little bit something that is really well structured, but also unstructured in terms of data.
But you're getting data from different sources, because you've got all of these different centers and all of these different clinical supports all pushing data through, right?
Yeah, that's right. And this is a really way much more complex, because not only I've got this, but also maybe I'm going, depending on my different patients, they will do a different test also. Okay. So that I will get also different kind of data modeling.
Yeah.
So that any patient is different.
But your data is going to be structured, unstructured, and semi-structured, right? Because it's a healthcare scenario, right?
Correct, everything. And this is where it's the beauty also of MongoDB, so that I've got also, I can ensure also a little bit of schema enforcement in order to be sure that my patient will be a patient. And the appointment will be an appointment. And same for a mammograph. I don't want to get the picture of my dog in the mammograph. It will make no sense.
So what does that look like then, Fred, in reality?
So in reality, how it's going to look like. So as you said, in fact, I've got different radio centers where all my patients will be there. And as you see, I've got the really different type of data that are coming from my different radiology centers. And all of these data are really centralized also within my global agency. So now let's have a look a little bit of our document model.
Let's see how it looks, yeah.
Yeah, so as you can see here, I've got a different table that are going to be a really, I would say, key with my prevention. I'm going to get a patient. I'm going to get the appointment, the study, the locations. So in fact, what I have and what we have built is something that where I need my application, I've based something that is quite key within MongoDB. So data that needs to be accessed together are stored all together. So that I'm really accelerating also my application, and I will be ensuring also that the developer that I am, and you are all, are really able to accelerate the development and really focus on the business and not on all the plumbing stuff there.
Okay, so we're not just doing slides though, Fred. Let's do a video and show what this actually looks like in Atlas.
Yeah, so let's have a look at how it's looked like from our side. And this is the database that we have, and within our application we have a couple of different databases, but we are going to really focus on one that is the virtual hospital. And if we look at the patient, in fact, we will see that we've got all the patients that are all the data, and they are really all well structured. We've got all the information, including also PII data. But not only for this, I've got also my collection about my appointment, where I've got all my relevant data, because when I'm going to do there, I'm going to do just an appointment. So all my data relative to my appointment are there. And I will be able to do all the follow-up, and depending on how my appointment goes, I will be able to really to add all the features that I will need, but also able to really to make evolving my applications as long as I need it.
So that's all the structure and how it's stored back in Atlas and in our documents and collections in MongoDB. So we've, as we said, structured, semi-structured, unstructured, we can accommodate it all. How is this going to play out then towards what a doctor would see? What is the process? And this is a real working app. We just don't have, well, we're not brave enough not to show just videos, you see. So we don't want to have any, but you can check this out. We can provide links afterwards as well too. This is a real proper running app. But let's look into the diagnosis then. So what happens when that patient turns up?
So in fact, when my patient turns up, in fact, the first thing that I'm going to do is really the testing. So we're going to get our patient. The patient is going to come, take the different mammograph. And one thing that will be really important is once I've got my mammograph, I need also to extract all the relevant information out of it. So do we have something wrong or not wrong, but also helping also the doctors in order to generate the reports, in order to ensure that they've got everything, and that's going to accelerate the treatment and all this kind of processing. And remember the use case that Rick said about Novo Nordisk, where we have accelerated everything. You will see live how it can be really accelerated by having using generative AI in order to generate my reports just based on my mammograph.
Okay, so we're going to get to the generative AI stage. What does that look like?
So how it looks like, a little bit one more time about the architecture itself. So as you can see, we are going to use a little bit of asynchronization integrations, because what is really important when we are doing a diagnostic, we have got maybe new additional also exams that are going to come. So I need also to update and be able to really update all my reports based on the latest information and the fresh ones that I have.
Okay, so that's where the change streams come in then.
And this is where the change stream come in. But not only this, because in fact what I want to get is also to keep the history of my different mammograph. And this is where in fact I'm going to store also my mammograph on S3 buckets, and all the metadata and my vector data and will be stored really within my document.
Okay, so the reference architecture coming up shows how this flow all is. That there's a lot of steps in here, but again, MongoDB makes it super simple. So maybe describe a little bit of it, and then we'll show the demo of this.
Yeah. So how it's working? In fact, we are going to take different memos. So that's 4 memos that we are going to take. Those that are going to be processed as images. What we want to do is really to get these images, and we are going to do not here Gen AI, but a little bit much more about ML on that sense, in order to get a scoring. And this scoring will be really able to help us if we are going to be able to detect things. And this is something that's going to help also the doctors, but also the radiolog, in order really to be sure that how it's going to behave. And so we're going to read the image. It's going to be uploaded and stored on S3 buckets. And we're going to compute the store, and the result of the store will be created within the document.
Okay, so I'm a doctor. I'm not technical. I don't care about reference architecture. What happens in the
Oh,
app?
yeah, you're the doctor. That's
I'm the
good.
doctor.
So that's
promotion.
good. Yeah, great promotion, Shane. So in fact, the first thing that you're doing, in fact, when you're arriving at your office is, first of all, you're going to look at all your appointments that you're going to get. And this is what you have. You see all the doctors there, and you see that we've got the different patients that are going to be ready for today. Now, the first patient, so Amelia arrived, and then she's ready for the mammograph. So we're going to take the different mammograph, and as you can see, we have it, and we're computing live, in fact, the biorad score that is
Live, but very speeded up for the purposes of our demo.
yeah, but it's just a couple of seconds, in fact. So it just has been speeded up. But one that's important is that once all my mammographs have been taken, I will be able to generate my clinic notes. So that based on all the observation that I had, straightforward, I've got it. But not only my clinic notes, I can also generate also my conclusions. So that I've got all my information that are really stored. Then what I will have just to save my report, and my data will be stored within MongoDB. So something that is great is that now let's see within the background what are the different stages that has been done. And one thing that we have done, first of all, we have generated our reports. So, and what we can see here is the data. We've got all my data that have been done, but also at the same time, we can see that we have also generated the report, the vectors out of it. So that's something that is great. But now, behind the scene, how it has been stored within MongoDB, and that's the second API call that I've done. And if you look at my document, so long document, I've got all the information about my reports. I've got my clinic notes, but also I've got my vectors out of it, so that when I'm going to do my search after, then I will be able to do hybrid search, semantic search, or just standard search.
Excellent. And as Rick said earlier, in the Novo Nordisk case study, from months to minutes, this is a reality.
This is the reality, right? I was just going to say, this is exactly, it's not the exact same workload, but it's a very similar exercise, right? Processing clinical studies results to generate those reports. Again, reduce that 6-month cycle to a 10-minute process. So this is watching that in real time. How long would it take that doctor to analyze all of those images, right? To review all of that data, to come up with those conclusions, and how accurate would he be? Versus how long would it take him to review the AI-generated response and compare that? Because often, I kind of look at this, I'm watching this, I'm going, this is just like Copilot. Right? It's just like when I write code with Copilot. It generates the code, but me as a developer, I validate it. So this gives the physician the same opportunity, right? Generate the response and use his expertise to validate it. Now that's essentially magnifying his ability to process information, right? Not replacing it, but just magnifying it. And that's what I love about this tool.
And the speed and keeping everything up to date, but the ability, once you've generated that report, is to leverage the information inside of that report, regardless of if you're the doctor or you're the nurse or the clinician involved. How does that work, Fred?
So, and this is something that is really important. And here, what the doctor are doing, or anyone, the assistant, or even the patient, if they want to look at have a look at the data. In fact, they're going to do natural language processing queries. They are not really familiar with any SQL or MQL query type of it. That would be really tricky. So what we are going to do is we are going to generate the user prompt. It's going to be passed and vectorized. And then we are going to get an API call that is going to provide us with the result.
Okay, so we saw the analysis of the mammogram earlier, but now we've taken Gen AI even further. Let's show how you interact with that by just asking the prompts.
So what we are doing is that currently what we want to get is something that where it's going to help also everyone within the company. And the good thing of it is that, as you can see, depending on your profile, we'll be able also to masquerade also your different data. And this is a good thing with the queryable encryption, so that only the people that are allowed to access the data can access the data. And here, as you ask, in fact, what we can see is the doctor will be able really to see all the data within a single place. So if I want to go a little bit further, in fact, I will be able also to do a little bit of analytics out of it using Atlas Chart, so that I can see all my data.
Okay, so you can interact with it, you can see it in the charts as well too, but also you can learn from it. And as you said, the patients themselves, when they go home, they could look up a little bit of information. And we're going to show a little bit too about how a RAG system is built here as well. So it's really the follow-on piece about the treatment after that.
Yeah.
And how do you run reports on how many patients showed up this month or this week or this year, between what age groups, et cetera, as well too. Super powerful in terms of query capabilities.
Yes, and this is something that is really important, because the next thing that we want to get to help the patient is really also to be able to follow up with the treatment and ensure that should we have any new things or new treatment that are going to come, then what will be the impact of the health of the patient. So this is where also we have a little bit of the follow-up there in order really to ensure if I have a patient that needs really urgent attention, how can I get it? So let's see a little bit into music, how it's going to be.
Okay, so in this, Fred, what are we seeing now? So what are we looking at?
So what we are looking at here is we are still our patient, but we want to really to get a little bit about the result and be able to search out of the result what we can get. And what is important is I'm the doctor, but there are new patients that came, and they may need also some recommended treatment or urgent actions. And this is why it's the beauty out of it with the semantic search. So show me all the patients that needs recommended action now.
Yeah, which is just a simple English prompt. You've typed in and got it. So you're not having to learn how to use the system. You can say, show me all the patients who need additional treatment.
Yes, that's it. But I can go one step further, in fact. I can ask also, show me all the patients that needs an urgent action, but also having maybe between a range of age. So, for example, show me all the patients that are between 45 and 65 and with suspicion of cancer. And then it will show me all my data and all my patients that are within this.
So we're doing hybrid search here with the pre-qualifier of the age, right?
Correct.
Okay, brilliant.
Correct. And I'm including also the result of the suspicion of the cancer. And all of this in a natural language.
Okay. So underpinning that then, as we spoke about RAG a lot, underpinning that is the ability to add research into your applications really easily by using RAG, uploading your docs in whatever format they might be, up to S3, for example, to create another feature that we've added to this application as well too, right, Fred?
Yeah, that's correct. And in fact, when you're the patient or the doctor, you're making some research, and maybe there is new things that are going to come up, and you want to apply it also to your patient. Or you're a patient, you're coming back, and you heard a lot of terms that you really don't really understand, and you want to know more about it. And this is where, in fact, this RAG chatbot can be way important, because here I will be able to load a bunch of info.
Though, Rick.
Here, that's the chatbot. For once, I've got one. But here, that's, I think, a useful chatbot, because it's going to be helping on the research, but not only on the research, it's going to help also my patient to go one step further. So how is my chatbot built?
Did you do the second click there? Oh, go back one. It might have just kicked off, did it?
Yeah.
I think there's a little pause of black before it gets going, or...
Looks like we don't have, there.
Oh, did it? Yeah, it was about to
I
start.
think we lost the video.
See, live demos, you gotta love them.
Yeah.
Well, live recorded demos.
Yeah,
Live recorded?
live recorded demos.
Yeah, I don't think the video's loading.
Well, look, in this piece, what we were showing was we took all the documents, we uploaded them, they were processed, and you were able to query them with natural language as well, too. So.
And this is something that is quite important, because what we are doing and what we have and what you can show, and you can come on our booth and I will be able to showcase it to you, is we have chunked all of the documents and all the large PDF that we have in order to do this. They are stored also with the metadata, all the information, my vectors within it.
You've got the references there.
And I've got all the reference in order really to go for
Perfect.
it.
Excellent. Thank you, Fred.
Thanks. So maybe Rick, if you can tell us what should I need to keep in mind following this session.
Well, obviously, the key highlights from the session here today in the MAP program, if you have an opportunity to look into this, if you're working on AI workloads within your organization, please take a look at how MAP helps organizations build and deploy modern apps, right? Hopefully what we showed you today was a useful use case for MongoDB and AI and building these types of pipeline workloads. And if you want to learn more about how MongoDB can help build AI workloads, then there's a nice link for you to follow. Please scan the QR code up there. And again, thank you so much for your time and appreciate your
One more plug from Fred, though, for the folks here today.
For those who are still here.
Yeah.
For those who are still here, we have also launched a new training free of charge, so that how to build this type of applications, GenAI applications on with MongoDB on AWS. So that if you scan this QR code, in fact, you will be able to register yourself for the training. And for the people that are here at re:Invent, if you're getting the learning badge, then you will be able to grab this nice backpack that you see.
Great.
Excellent.
All right. Thanks, everybody.
Thanks.
Thank you very much.